Hi, everyone. My name is Dean, and I'm going to be talking about unlocking data science teamwork using DAGsHub. A few words about myself. My background is kind of varied. I combined a bit of quantum physics, development, computer science, data science, and I sparkle in a bit of color with design. But for the purpose of this talk, what you need to know is I'm the founder of DAGsHub, a company which is building tools for data scientists and machine learning engineers. Basically, I think that taking the work that data scientists do and making it work in the real world is really important. And this, to me, is the essence of the MLOps field. So what am I going to be covering today? I'll talk about the DAGsHub mission, or why we exist, why we built the platform, ways that DAGsHub will improve your life, how DAGsHub does this, and then go over a feature overview and a brief demo of a live demo of the platform. Let you ask questions. We have a few other team members on the chat, so if you ask something, they will try to respond as quickly as possible. And maybe I'll start with a quote. No one can whistle a symphony. It takes a whole orchestra to play it. I think in a lot of ways, this embodies our philosophy that unlocking and enabling collaboration enables people to build things that are more complex, but also more awesome and powerful than they could on their own. And so that is why we built DAGsHub. So the mission is to make it easy for data scientists to work together. I think at this point, definitely everyone who's attending this conference agrees that machine learning has a major part to play in our future. But that does mean that you need to be able to scale your machine learning project. And when I say that, I don't only mean more layers to your neural network or more GPUs. It also means more team members. So if you're working alone today as the first data scientist in a company building out proof of concept, you'll soon find yourself working with a team and then maybe multiple teams trying to advance the same product or different parts of the same product. And you need to be able to do that effectively. And so this is where DAGsHub comes in. And DAGsHub users sort of enjoy life more by being able to have a faster and easier onboarding process. So that means taking new team members, onboarding them to an existing project. Handoff of projects between teams or between team members within the same team becomes much easier. You can split work between team members, and this translates directly into faster time to production or faster cycles. And finally, you can have a better review process. So it's easier to review each other's work. And this translates into less bugs and higher quality data science. So how do we do all of this? The first step is we don't reinvent the wheel. Wherever possible, we rely on existing solutions for a given challenge. And this stems from our belief that no one tool can be great at everything. You have a bunch of tools and you want to use and a bunch of problems that you want to solve. And you want to use the tools that are best suited for your needs. And so our approach is we see a problem that data scientists are facing. We do the market research for you, and we choose the best suited open source tool for the task. And the way we do this is we prioritize ease of use, flexibility, and sort of supporting as many workflows as existing workflows as possible. We choose tools that have an active community, so you're not alone in your battles. And we make it so that, and we choose the tools that make it so that it's easier to integrate future workflows, and it's as seamless as possible to do this. So after we choose these tools, we integrate them in a modular way. And what I mean by this is we don't force you to use anything. You can use only the tools that are relevant to your problems. And whatever isn't helpful, you can put it aside and maybe use it later if you want to, or not use it at all. And that lets us and lets you sort of rely on the best tool for a given task. Because again, integration makes everything easier. And the spice that DAGsHub adds onto this is we make these tools easier to use first by doing the DevOps heavy lifting, leaving you to decide how you want to use them within your project. So what does this look like in practice? The first thing is DAGsHub basically connects open source projects for machine learning. So the current snapshot of what DAGsHub does is connecting Git and DVC, MLflow, Jenkins, cookie cutter data science, and more. And again, in each one of these, we're working with generic formats, open source tools, so you can modify everything to your needs, even if your needs are non-standard, without losing the capabilities of the platform. And of course, we connect to the platforms that you're already using and familiar with. And this is sort of easy because, again, everything is open formats. So if your project looks kind of like this, so you have your code in one place, your data in another, your experiments in a third, notebooks in a fourth, and so on. The first idea with DAGsHub is we want to simplify all of that. So with DAGsHub, you get a single place where you can see your code, your notebooks, your data, your models, your pipelines, experiments, and then it connects to a bunch of plugins which help you automate and sort of simplify your life. All of this is done sort of in a zero configuration way. So with every DAGsHub project you create, you get a free built-in DVC storage and MLflow server, where on top of it, you get things like team access controls, the ability to compare any experiment and run you'd like, hosting data and code side by side, and even merging data. And with some of these other capabilities that we're adding is the ability to review anything. So that means compare Diff, all of these different files, such as notebooks, tables, image data, even MRI, and of course, textual data or code. And this lets you compare apples to apples and sort of make sense of the changes that you or other team members are making within the project. Now, we know that data scientists have sort of special use cases. So what happens if you have a data set with images and you change your pre-processing, and now 3,000 images have changed? So you don't want to see a flat list of 3,000 files that have changed, right? You want to be able to easily make sense of it. So one of the capabilities that DAGsHub has built in, especially for this, is the ability to diff directories. So you can preserve the project structure and context while you're diffing and understanding the changes that you made to a given project. Additionally, you can visualize your experiments, metrics, parameters, compare them, understand what experiments are performing better, and you should maybe focus on them, or worse than you should focus on them, depending on your task. We let you visualize your data pipeline or your project structure in an interactive way so that you can understand what components interact with what other components in your project. And again, this is built for data scientists from the ground up. So we continually think what you want to see when you're performing these different tasks and workflows, and then build that into the platform as much as possible. One of the other things that is a result of this is that reproducing a result becomes as easy as a single command. So this is possible, again, because all of the components of your project are in one place. So if you view your experiment tab and you find an experiment that you want, you can just git checkout and get your code, data, models, and everything on your system, whether it's local or cloud, and then just start working on it. So with that, I think this is going to be a good time to transition to the platform itself. So I'll stop presenting. Sorry, there. And I want to see what's going on. Cool. So this is DAGsHub. The first thing you might notice is that it's kind of like GitHub. There are a few differences you might have noticed, but the idea is you don't have to relearn a new UI from scratch to use DAGsHub, but things will be familiar with a data science twist. And this is a project that I'm actually working on, which is called SaftaDepth. So SaftaDepth is a monocular depth estimation project. So the idea here is you take a 2D image and you estimate the depth of each component within that image. And some of the things that you can do with it is you can basically use it for autonomous driving. So this is an example from another project called MonoDepth, which does the same thing. And then you can also use it to create 3D images. So it has like fun applications, but also real world uses that are potentially very meaningful, like autonomous driving. And when I started this project, obviously I was learning this thing as I went along. And so the first step of the process was to do a sanity check. Like I wanted to see that I can build something that actually works and it can learn something very simple. So the idea was not to start with a state-of-the-art model, but to actually get something like this. Like I want to input an image, I want to get out the depth map, and it should make sense. And the way I did that is probably like most of you do, and when you're in exploration mode, is you open Google Colab and you start experimenting. So the nice thing is, while I was working on this, I created a notebook folder and on DAGsHub, and actually, well, I guess I can go and see it from here. But this notebook sort of has this sanity check. So the idea was, let's load the data, let's train a very basic model on it, and let's see that that model can actually learn something. So everything exists here. You can see that there are some targets, and I guess this is the final version. So this is after I already trained a pretty good model, but to begin with, it wasn't so good. And so what I would do is I would work on something, and then I would upload it to DAGsHub, and you can do this via drag and drop or using Git. And then you can compare versions. So this is the version that I showed you a moment ago is the latest version. But if I go to a much earlier version, I can actually choose I have this compare capability, and I can choose a different version. And now this is a Jupyter notebook, and we can diff this inside the UI. You don't need to go to a separate dedicated platform or anything. And you can actually make sense of the changes. So you can see changes in my code, but you can also see changes in the outputs themselves and see images side by side. So the right side is the older version, and you can actually see, I'm not sure how big this image is for you, but if you look closely, you can see that this is the first prediction I made, which is not so good, but it was a sanity check. And the later model has much better predictions compared to the target. So you can see that I improved my project as I went along. So I have this notebook, and I finished the sanity check, and now I'm like, yay, I can actually do this. So the next step is going to be, let's build out a simple pipeline. And so with again, probably the first thing you noticed when I started scrolling down is that you have this sort of data pipeline functionality, which in this case is based on a DBC pipeline. So this is an open source, very simple format. I'll show it to you in a moment. And you can define the project structure, and then you can interact with it. So what I mean by this is, if you want to see what this file is, or where it's located, or what is the command that I ran to process the data, so you can actually expand this, zoom in, check it out. And even if, for example, you want to see the metrics, so I trained the model, I have this trainmetrics.csv, and we're actually showing you the metrics for your model within the UI. So it's easier for you to make sense of the project that you're working on, again, in the context of the structure. So one of the things, for example, that I did while building this pipeline is I wanted to see examples of what I'm predicting. So I created, for the evaluation step, I created an example folder. And if I click this button, I'm actually going to dive into that example folder, and I can open it and sort of see the predictions that my model is making. And I don't know if you can see this, but I'm actually navigating this with my keyboard. It's very intuitive, and you can actually see what's going on, again, in a way that's dedicated to browsing data sets and not just like single files. Okay, so I have this pipeline built out. It's pretty cool, but I want my work to be reproducible because I'm people, and hopefully with even more people in the future. And so the next step, or this was actually done sort of in parallel, is to make sure that I'm versioning everything. So what do I mean by that? As you can see here, you have a bunch of different nodes. So I'm obviously versioning code, but in this case, I'm also versioning the data, the models, the prediction examples. And you can see this in the pipeline, but you can also see this here. So if I go to the data tab, it shows me all the data that I'm using in this project. And I could go to the processed data folder, and let's say I want to see the test data, and let's say I want to take the bathroom. So I can open and see all of the images within this context. And all of these, if this isn't clear, all of these are tracked not by Git, but by DBC. But DAGsHub automatically parses all of this information and makes it human readable, so you can share it with people. You can download it directly from the UI, so if it's a model or something like that. And again, making sense of it is super straightforward and nice. So I have versioning built in. Again, this is relying on DVC. Oh, and I promised you I'd show you the pipeline structure. So if you open DVC YAML, you can see that it's very straightforward. Like I have stages, their names, the dependencies and outputs, and DAGsHub parses all of this and makes it the interactive, nice thing that you saw a moment ago. Cool, so where was I? I had a sanity check working, I built a pipeline, I'm versioning my data. So I'm already at a pretty good place. And the next thing is, now that I have everything ready, it's time to experiment, right? Like the first model, as I showed you, wasn't doing so well. And so with DAGsHub, you can do a few things. So first, you can track experiments with MLflow, but I actually didn't do this in this project. So using MLflow, you just, if you have an MLflow project, you can just add the DAGsHub URL, which you can see here actually. So every project comes with a MLflow remote. So you just put this in the MLflow remote URL, and it will automatically be logged here. But in my case, I used Git experiments. So what does that mean? So I guess you get this table of experiments that is automatically created. But just to show you how this is done, basically within my logs file, there is train metrics and a train parameters, and then a test metrics file. So I write using this format, and we have like a DAGsHub logger which automates this if you prefer to use it that way. But it's very customizable again, and like the parameters are a key value pair. So it's a very simple format which you can humanly read this. You don't need it's not some proprietary format which is strange or something like that. And then for the metrics, we're just using a very simple CSV. So like I showed you, we have like this interactive CSV viewing, but you can see that the metrics file is basically a CSV with a column of name, value, timestamp, and step. So you want to view it like this. You can also filter it, like let's say I want to look only at the train loss. So I can do this, and then I can actually see the value here. But obviously, this doesn't make as much sense as looking at the experiment table. So here I can see my different experiments. I can see the parameters in blue and the metrics in pink. And I can actually compare it as well. So I can choose multiple experiments, click compare. And then I can see all of these different experiments. I can see a side-by-side comparison. So this is a table with all my parameters and metrics. But I can also see this parallel coordinate plot. So I can see the effect that these different metrics, these different parameters have on the metrics. So I can open a bunch of metrics. And one surprising thing that actually happened here. So this is a good preview of what happened in my project. So I created these experiments, and then something strange happened. So what I realized is, for some reason, there was no correlation between training the model for longer and getting better results. So obviously, there is some problem here. And I couldn't really make sense of it. Like, how could this be? Like, I checked my data, and it seemed okay. Like, the training loss was going down as expected. So everything seemed to make sense. But then somehow the evaluation metrics. So here, I guess the way to show it, this is maybe clearer. So this is like a side-by-side view. And you can see that all of them, like, there's no clear winner. And the gray one here is the one that's trained for longer. Okay, so it's not clear that it's working better. So what I did is I went back and I checked out the examples. So I'll show you exactly what I did. And at the time, I was working on this branch called epoch testing. And when I went to my examples folder, so again, this is probably the easiest way to do it, I opened the image, and something sort of didn't make sense to me. Like, all the training data that I had, the image was like sort of darker for closer, and here it seemed like it was darker for further away, and I didn't understand what's going on. But at some point I realized that I was saving the values inverted. So everything that was supposed to be black was white, and everything that was white was black. And so I got the exact opposite of what I wanted, and that made the metrics go crazy. So obviously I fixed that. So I had this new branch called epoch testing fixed. And you can actually see this change in DAGsHub in a very intuitive way. again, understanding what's going on, it just makes sense. And I can actually share this with my teammates and show them like, this is the issue, here's how I fixed it, here's why it worked. So when I did that, the next step was to create a pull request. And with DAGsHub, creating a pull request, so this one is actually already closed, but the thing was, after I create a pull request in DAGsHub, you can also see the files that were changed and the experiments that were added in this pull request. And then after it's merged into master. So again, you see the same diffing that I showed you earlier as part of the pull request as well, which is pretty awesome. And the experiments that I contributed. So, oh, sorry. If I go to the experiments tab here, and I reset my filters, then I can go to, these are my most recent experiments. And then when I compare it, if I compare these new experiments, I get the same view as before, only this time when my charts are loading. So just a moment. This is live demos for you. But now everything makes a lot more sense. So again, on the right is the one that's trained for the longest time, and these metrics I want higher is better, and all of these metrics lower is better. So I see that I'm getting what I expected, which is awesome. So that was a success, and now it can be merged into production. So that's where I stopped. But there are some open issues here because we're looking for contributions, and this is entirely open source. Like everything I showed you is available. You can go to Soft2Depth on DAGsHub and see all of this. So next steps would be to add automations. Like I said, we're integrated with Jenkins, so you can add automatic training when you open a pull request or deploying to production when it's merged into master. We want to add an integration with Streamlit so you can actually interact with the model as part of the sort of in a convenient UI. There are a bunch of other issues, and I invite you all to contribute. I think this is a good place to stop and invite you to ask questions if you have any. Let's see. Okay, so I see there are some questions here, and I see someone, Zachary. So Zachary, I think, I don't know if you remember me, but so Zachary helped me out with Soft2Depth with one of the challenges that I had. I was using Fast AI for this, and I had some challenges building out data loader. So thank you. But I see Guy already answered your question. Anyone else have questions? Someone want to join maybe and ask live? Awesome. So Artem is asking about DAGsHub hosting. So everything that I just showed you is hosted on DAGsHub.com. You can start using it. It's free. It's always free for open source. It's also free for private projects up to a certain collaborator limit. There are solutions for on-premise, but that's part of the paid offering. But we sort of honestly believe that it is really important that you as a data scientist understand the value that you're getting. And that's why all of the features that I just showed you and all of the features that we have on DAGsHub are completely free to use. And then if you already know that they're valuable to you and your team is scaling and you need this on-premise and everything, then you can take it to the next level. So the data is hosted on, so there are a few options. Like I said, integration, easy integration is what we do. So when you create a DAGsHub project, you get built-in DAGsHub storage. So that's a DVC remote, which is hosted by us, and you can push your data there. And the reason you'd want to do that is, again, you don't need to do anything. Like it automatically comes with a project, and it's free. And it's you get like team access controls and all of these other things. But we realize that some teams have either really sensitive data or they already have a cloud setup and they want to connect their existing cloud setup. So what you can do is you can also connect your S3 bucket or Google storage to DAGsHub. And then give us permissions and we can show you all of the other features. Or if you decide not to give us permissions to read your data, then you can see the structure of the project and actually get links back to the data without letting us show them to you via the UI. So it's very flexible. You can decide what you want to use. Yeah. Any other questions? Okay, awesome. So I'm going to be staying here for a bit longer. If more people are joining, we'll do another round of this. But feel free to stick around and ask more questions. We'd be really happy to answer them. I'm actually interested from the people that are here, if you'd be willing to share what type of projects you're working on. Like, are you working on computer vision, NLP, I don't know, medical data, something like that? And maybe what challenges are you facing with respect to your productionization or your workflow? Okay, so we have one computer vision representative. Any other challenges that you'd be interested in, like to hear about? Like, one of the things that we do, I would say for fun, but it's also like part of the job is to sort of learn about all of these different tools. And again, we have a lot of content on what open source tools make sense for what use case. So if you have questions about the broader pipeline tooling that you're not sure which solution to use, I'd be happy to answer that as well. Okay, okay, let's see. Yes, so Git like diffs is definitely part of our core offering. It's, yeah, like our approach is basically like, I actually, this is one of our catchphrases. I didn't say this in this presentation, but our approach is that data should be treated as source code. And as such, it means that you need to be able to track it, diff it, make sense of it, and review it in a meaningful way. Otherwise, you're only seeing part of the picture. So, yeah. Okay. Yeah, so, okay, so there's a good comment and a good question here. The data scientists need to get used to Git. So I think that the idea is to make it as simple as possible for them and to sort of maybe in a sense, meet them halfway. So build capabilities that they need and they can sort of ease into using Git. So one of the examples is, again, notebook diffing. I know that a ton of data scientists need this. And I think DAGsHub makes this easier than any other place. And you don't have to start, like, you can create a project and start dragging and dropping notebooks to begin with. I don't recommend this for large scale projects, but if you're getting started, then that might make sense for you. And I think we're going to provide you value from that step forward. And then with respect to comparing this to SageMaker experiments and weights and biases. So I think that there are a lot of really great solutions for experiment tracking today. For us, maybe I should explain the logic behind integrating first with MLflow is A, that it's open source. Like I said, I think this is an important consideration. And then B, that it's very, very widely adopted. So I know that SageMaker and weights and biases are also very widely adopted, but for us, this made the most sense. Also, it's very flexible. A lot of people are using it in very different types of projects, et cetera. But I will say that we have users that are using DAGsHub with weights and biases. And I think that and also I'm guessing SageMaker experience, even though specifically I haven't heard someone who's using both. But the idea is DAGsHub is not just an experiment tracking tool. And I would say even more than that, experiments is one component of a data science project. So we believe that you have to have experiment tracking to make sense of your project. So it's necessary, but not sufficient. And I think that the thing that DAGsHub does exceptionally well is combining this with the data management part. So the ability, again, to diff data, to see and version your data in an interactive, collaborative way, that's what we do best. Plus adding on top of that, the ability to actually review your data and your changes in data and your changes in experiments all in the same context. I think that's the main added value that we're bringing to the table. But that being said, each of these tools have their strengths. And so I don't see that it's either or, they can actually work together. I hope that answers the question, but if not, feel free to press me on it. In the meantime, let's see if more people have joined. No, we're still, I think it's still the same. Okay. So I think more people have joined. So I'll answer this last question and then maybe we'll do the presentation again. Do you plan tighter integration with GitHub? Okay, awesome. So thank you for asking me great questions. This is a great question because to be honest, the GitHub integration, so DAGsHub has a GitHub integration, which makes it, you can sign up with GitHub, which is awesome. But the other thing that we built, and actually I need to sign in, but this is not my regular, it's not my regular browser, so maybe I'll share another screen. Basically, what you can do with the GitHub integration is you can also have an easy import, which is exactly what you asked. So once you sign up with GitHub, we will enable you to click Connect New Project. You will then be able to see all your, you need to give DAGsHub access to see your projects, but we'll show you all your GitHub projects and we'll let you select one from there to import it. So in this case, just to show you how this looks, I do create new connection, and then I have this GitHub Connect. If you have a URL and you just want to do it the old school way, then you can click this and it's the same connection that you're familiar with. But here we have this tighter integration with GitHub where you're going to do connect. And this has now scanned my GitHub account and is showing me all the repos that I have here. And I can actually I don't know, let's see, Bert. So I can actually click this. I can see a bunch of information about this, like who are the other contributors and everything. And then I can just click connect repository and it's going to be connected. So this is basically, if I understand correctly, this is exactly what you asked and this exists today. If you have, I guess I'll end with this. We are very much open to suggestions and feedback from the community. So if you liked what you saw, but you need an extra thing, or you have an idea for how DAGsHub could be better for your use case or for the community, then we would really love to hear that. We have a Discord channel that we invite you all to. We'll add the link in the chat in a moment. And so I think that's really important for us. And if you have open source data science projects, so you want to work with other people on your data science projects, come to DAGsHub. That's what we were built for, and we'd love to have you. Of course, companies and everyone else can also join, but this is sort of something that we care deeply about, and we invite you to join. Cool. So with that, thank you for all the people that have joined. If you want to stick around for another run, then you are more than welcome to do that. I'm going to restart everything, just start from scratch, the presentation and everything. So let me just close all of these windows. I guess I'll leave the experiments open because why not? Cool. So, and I'll refresh this just so it's really back to square one. Cool. And let's preview the slides and go back to the beginning. Okay. So hi to everyone who joined. You know what? I'll take a sip of water. I'm Dean. Nice to meet you all. Thank you for joining this event. So I'm going to be talking about unlocking data science teamwork with DAGsHub. And this is going to be a relatively short presentation. I'll leave room for your questions. As you've seen, the earlier group has asked a bunch of them. So feel free to ask. We have other team members on the call, and they'd be happy to answer. So you can type in as I'm going along. I probably won't see it, but someone else from the team will answer. So a few words about me. My name is Dean. I have a kind of varied background, combining physics, computer science, data science, and sparkling in a bit of color with design. What you need to know about me for the purpose of this talk is I'm one of the founders of DAGsHub, a company which is building tools for data scientists and machine learning engineers. And basically, I think that taking the work that data scientists do and then making it work in the real world is really important. And this, to me, is sort of the essence of the MLOps field. So we'll be reviewing today the DAGsHub mission, why we exist, ways that DAGsHub improves your life, how we do it, how do we make the magic happen, and sort of brief feature overview / live demo of the platform, and then we'll open it up for your questions. So I'll start with a quote, which is, "No one can whistle a symphony. It takes a whole orchestra to play it." And I think that this embodies our philosophy at DAGsHub, which is that unlocking and enabling collaboration enables people to build awesome things, more complex things, and more powerful, and get more powerful results. And we're doing exactly this, so unlocking collaboration for data scientists. How do we make it easy for them to work together? Now, I think at this point, especially for people that are on this call and joining this event, everyone agrees that machine learning has a major part to play in the future. We're beyond the point of doubt on that one. But that does mean that you need to be able to scale your machine learning project. And I don't only mean that you need more GPUs or more layers to your neural network. It also means that you're going to grow your team. So if you're a lone data scientist working on your proof of concept for the startup that you just started, hopefully in a short while, you're going to have one team, then multiple teams, then maybe a whole department of data scientists. And they're all going to be working on the same product or on different parts of the same product. And they need to be able to work effectively together. So in that sense, DAGsHub comes to the rescue, and DAGsHub users enjoy life a bit more because they have faster and easier onboarding. So taking new team members and onboarding them to an existing project is much faster and easier. Project handoffs between teams or within the same team between team members are much more efficient and effective. You can split work. And by this, I mean multiple data scientists can work on the same project on different aspects of it or different parts of the pipeline, which translates directly into faster time to production. And you get a better review process, which means it's easier to review each other's work. You get less bugs and higher quality data science, which is awesome. So how do we do all of this? Step one is don't reinvent the wheel. Wherever possible, we rely on existing solutions for the challenge. And this stems from our belief that no one tool can be great at everything. You want to use the tools that are best suited for your needs. Now, what this means in practice is we see a problem that data scientists are facing. The next step is we do the market research for you and choose the best suited open source tool for the task. Now, what does it mean? What does this mean? First, we prioritize ease of use, flexibility, and tools that support as many current workflows as possible. The other thing is we're looking for tools that have an active community because we don't want you to feel like you're sort of alone in this challenge. And finally, we're looking for tools that make integrations of future workflows as easy and seamless as possible. Then we integrate it in a modular way. So this means we don't force you to use anything. You can use only the tools that are relevant to your problems or workflows. You don't need to use anything that isn't helpful for your current needs. And you can sort of grow and expand as your needs change. So if you're currently just working with notebooks, and again, it's a proof of concept, tomorrow you want to add data versioning, we'll make that addition super easy. And this also means that you can rely on the best tool for a given task. And finally, we add some of the DAGsHub spice. So we make these tools easier to use, mainly by doing the DevOps heavy lifting and leaving you to decide how you want to use them for your project. So how does this look in practice? At a high level, DAGsHub connects open source for machine learning. So in our case, the current snapshot of where DAGsHub is, we connect Git, DVC, MLflow, Jenkins, cookie cutter data science, and more, working with generic formats and open source tools so you can modify them to your needs, and even if your needs are non-standard, without losing the capabilities of the platform. And of course, we connect to the platforms that you already use and are familiar with, and that is sort of easy because we're based on open formats. So if your workflow looks something like this, where your code is in one place, your data is another, experiments in a third, notebooks in a fourth, and everything seems like a bit of a mess, DAGsHub is going to simplify your life by connecting everything and showing and giving you a single place to see your code, notebooks, data, models, pipelines, experiments, and connecting to different plugins to automate or simplify the workflow. And on top of all of this, we're adding sort of the zero configuration aspect. So with every DAGsHub project today, you get a built-in DVC storage and MLflow server, on top of which you have team access controls, the ability to compare any experiment and run within the project, hosting code and data side by side, and even data merging. And a bunch of other things that we let you do is you can review anything. So comparing and diffing things like notebooks, like tables, so like table diffing, image diffing, even MRI data, and of course, text or code files. And you can compare apples to apples and make sense of the changes in your project very easily. One of the things that has come up is what happens, for example, if you have an image data set with, let's say, 3,000 images, and now you're changing your pre-processing, and all of those images have changed. Okay, let's say you changed normalization. This is a recurring theme. It's going to appear later. So now you have these 3,000 files that have changed, and you definitely don't want to see a flat list of 3,000 file changes. So with DAGsHub, one of the things that we enable you to do is, for example, directory comparison, which means that you preserve the context of your project structure while diffing and understanding the changes that are going on. In addition to this, again, experiments are an important part of every data scientist's diet. So with DAGsHub, you can visualize your experiments, metrics, parameters, compare them, see the charts and all. And this is super useful to understand where you want to focus your efforts and where not. And you can also visualize your project structure and your data pipeline, again, in an interactive way, understanding how the different components interact with each other, which is awesome. Now, all of this is built for data scientists from the ground up. And we are continually thinking about what you want to see when you're doing you're going through your workflow, and sort of try to build that into everything that we're doing. This also means that reproducing results, which is super important, becomes as easy as a single command. So if all of your project components exist in one place, when you do git checkout, you should get your code, data, models, and everything on your local or cloud setup so that you can just start working. I think this is a good point to stop and to move to the live demo of the platform. So let me just shut this down. Here, sorry. Logistics of sharing things. Cool. So, so this is DAGsHub. And this project is a project that I've been working on for a while now. It's called SAFTA Depth. And this is a monocular depth estimation project. So what does that mean? The idea is you take 2D images, maybe one that you took with your phone, and then you try to predict the depth of each object within the image. So this is a nice problem to solve because it has a real world application. So this is a GIF from one of the state-of-the-art papers for this. And you can maybe you can intuitively understand that this is something that's useful for autonomous driving, which is obviously state-of-the-art ML and everything. But it can also be used to do a lot of really cool stuff like this. So creating 3D images, which is something Facebook is awesome at. And so that's why I chose the problem. It's fun, but it's also useful. And so the first step was to do a sanity check, because this was the first time I was working on this kind of problem. And so what I did is I created a notebook. And again, you can see here with DAGsHub, we have like tabs to help you navigate your project. And this notebook is a sanity check notebook. So the idea was I started it in Colab, like you probably do when you're exploring stuff. Free GPUs are hard to beat. And sort of what I did here is I just loaded the data set, like a simple data set. I created the simplest model that I could think of, and I just wanted to see that it actually learns something. So what you can see here is sort of like, well, there's a lot of logistics, loading the data and everything. But if I scroll down after all of this training and stuff, I get some of the results. Oh, sorry. Okay. Let's go to the correct place. There. So if I go, I could see sort of these images and the predictions that I've made on top of them and compare it to the target data and everything, which is awesome. But again, I was doing this on Google Colab. So why are you seeing this here? Every time I had a meaningful, version to check in, I would commit that to DAGsHub. Now you can do this either with Git or directly by dragging and dropping the notebook in. And that lets you sort of diff your notebook. So as you go along, if I show you an earlier version, like this is the latest version for my project, but if I show you an earlier version, I can actually open it with the compare tab. And DAGsHub will show me a human readable notebook diff. For those of you that are working with notebooks, this is probably pretty nice. I think DAGsHub does this in an integrated way, so you don't need to go to a dedicated platform to see your changes, and it's actually very easy to see how your code changed, but also these different outputs and sort of compare the model that is compare the work that you did in the notebook to an earlier version. In this case, on the right, you can see the old version. I just now realized why the notebook is different, because the one on the left is not the latest version. So let's change it to that. This is the actual diff that I wanted to show you. But this, I think this shows you how easy it is to move between different versions that you want to diff. So this one makes a bit more sense. And you can see on the right is the older version. So I don't know if you can see this big enough on your screen, but this is the first prediction I made, and it looks kind of horrible. This is the best model that I created, and you can see that it looks kind of the same as the target, which is pretty awesome. So you can see I actually improved my work, and it's not just a makeshift example. But okay, so I had this sanity check. I realized that I could learn something, like the model could learn something, and now it's time to take us to the next level. So what is the next step? I want to build a pipeline. What does that mean? I wanted to define the project structure so I can sort of make sense of what's going on. And DAGsHub gives you exactly that. So if I scroll down, I get this pipeline. I'll expand it so you can see it on the entire screen. Now, this is a DBC pipeline. And DAGsHub sort of automatically creates this interactive view of it, where even if you have non-technical team members and you need to explain to them like what's going on in your project, it's very easy to do based on this visualization. So I can tell you that I'm taking a standard data set from the internet. I'm starting to track it with DVC, that's the dark blue nodes. I'm processing it and getting some process data, training a model on my trained data set, evaluating that model on a test data set. And then in the end, I get sort of this metrics and examples, which are a few predictions that my model has made. So I can look at the results qualitatively. And this is interactive in the sense that if you want more details about the data, you can click on this node. If my internet doesn't betray me. Wait a minute, sorry. Sorry, the internet is... Okay, so I can click on this and see the details of my data, or click on my command and see sort of what command I ran for this processing step. And I can even see my metrics within this pipeline. So if I want to see how this model performed in training or perhaps in testing, I can actually expand this and see the different results my model has had. And this is also interactive in the sense of, let's say I have this model and I want to see the prediction examples. So I can open the examples node and then click this link. And now I'm going to be directed directly into this folder. And I can open each image and see what my model is actually predicting. I think my internet is betraying me. Okay. You always have to hold out hope for the internet in these live demos. But anyway, you can scroll, you can sort of browse through your data very intuitively with your keyboard and sort of make sense of what's going on in your project. Okay, so I have this pipeline. I did my sanity check. The next step is I want this project to be reproducible because I'm working with other people. I need it to be easy for them to take my data, my code, my model, and then modify it so that they can contribute. So the next step, which is actually a parallel step to building this pipeline, is to start versioning all of these different project components. So in this case, I want to track my raw data, which is not going to change that much, my process data, which changes according to the processing step, my model, and my examples. And this is, again, in addition to code and metrics and all of these stuff that I would definitely track. And the nice thing about DAGsHub is now, let's say I want to see my data, so I can browse through it, but let's say I want to go directly to my data. I can click the data tab, click the process data, which is more interesting than the raw data. Let's say I want to go into train and I want to see my cafe pictures. I can do that. I can load them and sort of see the data sort of very easily. Which is pretty awesome. That also means that if I'm changing processing and I want to show it to someone, I can just send it to them and they can open it up and see everything from the UI. If they just want to download the model to try it out, they can just download it straight from here without typing in a line of code, which is pretty awesome. And that's it. So I'm using DBC to track the data and models. I'm creating this pipeline. This is how it looks behind the scenes. So it's a simple YAML that has like the stages. It has commands, dependencies, and outputs. And DAGsHub parses this and creates this interactive pipeline that I just showed you a moment ago. Okay, so sanity check, check. Pipeline, check. Data versioning and reproducibility, check. Now that I'm done, the next step is, okay, let's experiment, right? So for experimentation, DAGsHub provides two types of experiment tracking support. You can use MLflow, which I didn't do in this project, but then we have other projects that do use it, where the idea is you don't need to change anything from what you do regularly with MLflow, but you go to this remote button. You can see an MLflow remote. You copy it in, put it in as a remote URL, and then everything is logged to DAGsHub, which is awesome. But here I used Git experiments. So what does that mean? Every time I created an experiment, I logged these parameters and metrics. So parameters are logged as YAML file, which is human readable, like it's the name of the parameter and its value. And metrics are logged as CSV. So again, DAGsHub shows you this interactive CSV viewing. But you can see that it's basic, like 4 columns, so name, value, timestamp, and step. And if I want to filter it to only look at the raw loss, I can actually type in this name and only see the raw loss, which is pretty cool. But for most of you, you want to see the charts, right? Like this is not as interesting. So if I go to my experiments table, my experiments tab, I can see my experiments table, in which every experiment is a row. And basically, you can sort of see that I have these 3 experiments. The difference between them, in this case, my experiment was, let's try training the model for longer. So I can click these, I can click compare, and then I can make sense of the changes. So I have this tabular comparison where I see all of the parameters and the metrics of my model side by side. But if I scroll down, I'm also going to get my parallel coordinate plot, which is, if you're not familiar, it helps you see the effect of different parameters on your metrics. So I can see some of the parameters that I'm using, and I think my internet is again slowing down. There. So I can see the parameters that I'm using. I can see all of these different metrics that I have, and I can see how they are affected. So in this case, these are the results that are good. So this is, you can see on the right is the model that was trained for the longest time. Unsurprisingly, it has better scores on everything. So in these 3, higher is better. In these 6, lower is better. And so you can see my longest trained model is the best on all fronts, which makes sense. But it was not the case before. So when I started out, I actually had this, bug, which, let me just show you. So I had this bug where I created these 3 experiments. So I trained them like you saw before. So 1 epoch, 10 epochs, 50 epochs. And then when I clicked compare, I was looking at this and something didn't make sense. So as you can see, even from this just one metric, right? So as I said, here, higher is better. You can see that for some reason, 10 epochs is doing the best. 50 epochs is in the middle, and 1 epoch is worse. And that doesn't really make sense. And once everything loads, you're going to see that all of the parameters, the metrics don't really make sense. Like it's all over the place. There's no clear winner. I don't understand what's going on. So this is actually what I got. So the gray one here is the 50 epochs. And I'm looking at this and like something here doesn't make sense. So I went back to the data because as you all know, usually the issue is a data issue. And in this case, I saw that my data makes sense, like the process data. But one thing that I noticed is I checked out all the data steps. So I just went after like the raw data is raw, so there's nothing to look at it. I looked at the process data. I saw that it makes sense. But then when I looked at the examples, I went into this. So it was this was my branch. So I went into the examples. And by the way, you're now seeing how I'm transitioning between different versions. And I saw that something here is off. Like I was looking at training data, and then I was looking at the prediction, and everything looked the opposite. So in the training data, black colors were closer to the screen, and here it looked like the closer something is, it's white, it's brighter. So I didn't really understand what's going on. But then at some point, like I understood what happened, which was I was just flipping all the colors. So everything that was black was saved as white and vice versa. So I fixed this pretty quickly. And I could show this to my collaborators because I created this new branch, which is called Epoch Testing Fixed. And you can actually see intuitively side by side what has changed between these versions. And everyone can make sense of it because it's sort of so intuitive and in front of you. But now you can see it side by side, shared with your team members. Makes this more collaborative effort. And once I did that, I got the experiments that I showed you earlier, and I was happy. And so that's it. There are a few next steps. So at that point, I created a pull request, and in DAGsHub, you can see your data and your experiments in the pull request as well. But there are next steps. So I created a bunch of issues here. And this is an invitation for everyone listening to join and collaborate. So this is entirely open source. You can use this project. You can download it, use just the model, or actually contribute. And we've created some issues that are relevant. Some of the things are like, I want to add automations using Jenkins, like I mentioned before, DAGsHub integrates with Jenkins. So maybe automating training of the model or automating promoting a model to production. We want to add a Streamlit app so you can interact with the model with a nice UI. So there's a lot of work to do, and I invite you guys to collaborate. I think I'll stop at this point, and I'll let you ask me questions if you have any. But yeah, I think this is a good place to pause. So any questions, feel free to write them in the chat, or if you want, you can also join the video and ask them there. Yeah, so I'll let you think about it for a moment. Okay, so in the meantime, I'll say, while you think about questions, I'll say that we have a Discord channel, and you can join it. We'll add a link in the chat, and there we'll be able to answer any other questions that you want. But you can also, by the way, you're seeing this on DAGsHub, so here's the link. If you click this, you can join our Discord channel very easily. Anyway, if you are, so DAGsHub is completely free for open source projects, but also for private projects. So you can just start using it. All of the features exist. You can see that it's useful for your workflow. And if you're working on an open source data science project, then we especially invite you to come over. That's something that we deeply care about. And so if you're working on something that you want to share with the community, DAGsHub is especially the home for you. Great. Anyone have any questions? If not, that's also okay, like no pressure. Okay. So I'm going to stick around here. You can ask questions if you want. If you need to hop on to the next thing, it was a pleasure having you. And I hope to see you on our Discord channel or building awesome projects on DAGsHub. Thank you. So I'll be taking a 1 minute break, and then I'll join back here. But feel free again to ask questions, and I'll respond. So I understand that a lot of people have joined from other talks. If you will stick around, I'll start another round of this presentation. So don't leave us yet. You know what? I'll start now, just because I know our slot is ending. Like, we have 20 minutes, and I want to make time for everything. But feel free to. What I said before is we have team members on the channel, on the chat. So if you have questions while I'm presenting, don't wait. Just type them here, and someone from the team will answer. So with that, I'll get back to the presentation. Just a moment. Power of. Okay, so let me also close all of these windows. Cool. And refresh so everything goes back to before. Okay. So hi, everyone. Hi, everyone that's joining. This was going to be the last run of the presentation for today. So my name is Dean, and I'm going to be talking about unlocking data science teamwork with DAGsHub. What you need to know about me, or a short background, is I have sort of this varied background combining physics, computer science, data science, and sparkling in a bit of color with design. But for the purpose of this talk, you should know that I'm one of the founders of DAGsHub, a company that is creating tools for data scientists and machine learning engineers. Basically, I think that taking the work that data scientists do and making it work in the real world is really important. And this, to me, is the essence of the MLOps field. So what we'll be covering today is the DAGsHub mission. Why do we exist? The ways in which DAGsHub improves your life, how we make that magic happen, and a brief feature overview and a demo of the platform. I'll start with a quote. "No one can whistle a symphony. It takes a whole orchestra to play it." I think this exists on our site as well, and I think this really embodies our philosophy at DAGsHub, which is unlocking and enabling collaboration helps people build more awesome things, more powerful tools, and a lot of really amazing stuff. And so what we're doing at DAGsHub is making it easy specifically for data scientists to work together. So I think at this point, especially the people that are here listening, agree that machine learning has a major role to play in our future. But that does mean that you need to be able to scale your machine learning project. And when I say that, I don't only mean more layers to your neural network or more GPUs. I also mean more team members. If you're a solo data scientist working on a proof of concept for a small startup, hopefully very soon you're going to have a team around you and then multiple teams in the whole department. And you want to be able to scale your workflows in such a way that you're actually doing more effectively. So DAGsHub sort of comes to the rescue in this sense, and DAGsHub users enjoy life more by having faster and easier onboarding, taking new team members and onboarding them to an existing data science project. Handoff between teams or within the same team between team members becomes much easier. You can split work, so having multiple teams working on the same project, which translate directly into faster time to production. And you have a better review process, which means you can more easily and effectively review each other's work. And this translates into less bugs and a higher quality data science project. How do we do all of this? So step one is don't reinvent the wheel. Wherever possible, we rely on existing solutions for a given challenge. And this stems from our belief that no one tool can be great at everything. And you want to use the tools that are best suited for your needs. So with DAGsHub, we see a problem that data scientists are facing. We do the market research for you and choose the best suited open source tool for the task. What I mean by this is we prioritize ease of use, flexibility, and tools that support as many current workflows as possible. We're looking for tools with an active community so that you're not alone in your challenge. And we're looking for tools that make integrations of future workflows as easy and as seamless as possible. Then we integrate it in a modular way. We're not forcing you to use anything. You can use only the tools that are relevant for your problems. You don't need to use whatever isn't helpful for your needs. And you can. That also means that you can sort of rely on the best tool for a given task. You can sort of start with something small, just using notebooks and notebook diffing, and then expanding to other capabilities of the platform. Finally, we add sort of the DAGsHub spice. So first and foremost, we make these tools easier to use, mainly by doing the DevOps heavy lifting, leaving you to decide how you want to use them within your project. So how does this look in practice? At a high level, what we're doing with DAGsHub is connecting open source for machine learning. The current snapshot of what we are doing is combining Git, DVC, MLflow, Jenkins, and cookie cutter data science, working with generic formats and open source tools so that you can modify everything to your needs, even if your needs are non-standard, without losing any of the capabilities of the platform. And of course, we connect to the platforms that you're already using and are familiar with. And this is easy because, again, everything is based on open formats. So if your project looks something like this, your code is in one place, data is in another, your experiment notebooks in a fourth, DAGsHub will make your life better by connecting everything and giving you one place where you can see code, notebooks, data, models, pipelines, experiments, and connect to plugins to help automate your work. And on top of that, we make all of this sort of zero configuration. So with every DAGsHub project you create, you get a built-in DVC data storage and MLflow server with team access controls, the ability to compare any MLflow experiment or any experiment, not just MLflow, side by side, hosting data, hosting your data and your code side by side, and then even merging your data. Some of the additional capabilities we build on top of that is the ability to review anything. So in this case, you can compare and diff things like notebooks, tables, so generic format, CSVs, we can show you a diff of them, image data, even MRI data, and of course, text or code, which translates into you being able to compare apples to apples and make sense of the changes in your projects. Now, what happens if you have an image data set with like 3,000 images and now you're changing the processing and you have 3,000 files that have changed? What you definitely don't want to see is a flat list of 3,000 changes which you won't be able to make sense of. But one of the things that we built with DAGsHub is the ability to do a directory diff. So you can compare different versions while preserving the context of the project structure so that it's much easier to make sense of the changes that you did, even if there are very extensive changes like changing every file in your data set. Other things that we do is we let you visualize experiments. So you can see metrics, parameters, your different charts and metrics, and then compare them in a meaningful way. You can view an interactive project structure or your data pipeline to make sense of what components are interacting with what other components in your project. And all of this is built for data scientists from the ground up. So at every step of the way, we ask ourselves, what do you want to see when you're working on your projects, and then build that into the platform. And one of the results of this is sort of reproducing results becomes as easy as a single command. So if your code and your data and your models all exist in one place, when you do git check out from DAGsHub, you can get all of them to your local or cloud system and just start working and modifying things. So that's pretty awesome. And with that, I think I'm going to transition to the demo. I think I'm good on time. Again, I'll stop methodically to remind you that if you want to ask questions, you can do it. You can do it via the chat right now. Our team is here listening and will respond. So this project is called SoftDip. This is a project that I've been working on in my spare time. It's a lot of fun. And this project is a monocular depth estimation project. What does that mean? I'm taking a 2D image, like you can see here. This is Sunny. She's my dog. She's actually here in the next room. And I'm trying to estimate the depth of each one of these components within the image. So why does this matter? Well, there are two main things that you can do with this. One is just cool. So you can have 3D images, 2D images turn into 3D images. This is a work done by Facebook, but it's not just fun. And monocular depth estimation is very important for autonomous driving. So this is, on one hand, a fun problem and a relevant, realistic problem. It's not just a toy problem. So with that, I have never done monocular depth estimation before starting to work on this project. So the first step for me was I wanted to do a sanity check to make sure that I can build this thing, that I can create a model that actually learns something, and that I'm not just wasting time on something which is not feasible for me. So like many of you do, I went to Google Colab. Is awesome. And I created a notebook and I started working on my project. So on DAGsHub, I can see that notebook because I put it on DAGsHub. So I can go to my notebooks tab. I can also see it in the general tab, but I can open this and now I can actually see my notebook for this project. Now, this project, basically what's happening in this notebook is I'm loading the data as simply as I could. I'm training this super simple model that won't take a lot of time because that's the most sort of important part. And then I wanted to make sure that I'm getting some reasonable results and that it makes sense. So this is actually what you're seeing here is not, this is the latest result I have. But when I got started, my model didn't perform this nicely. But what I would do is every time I would make a significant change, I would commit this to DAGsHub. Now you can do this either via Git, or if you prefer, you could just drag and drop your notebooks into the platform, and then you can compare them. So if I want to go to an older version so that you can see some changes, I can use the last version of my sanity check. And here you can see a human readable diff. So if you're familiar with notebooks, you know that diffing them is not so trivial, and usually it's really hard to understand what changed. But with DAGsHub, you can do that as part of the platform. It's completely integrated, and you can see the code changes, but you can also see the output changes. So you can see on the right here, I'm not sure how big this is, but you can see that my initial model wasn't really good, and the latest model is much better. So what this means is I can actually send this link to you guys, and you can open it, and you're going to see the same diff. So it's really easy to share and discuss this work with your team very, very sort of intuitively. Okay, so I built a sanity check, and luckily for me, I managed to build this super simple model that can learn something, and now it's time to take it to the next step. What was the next step? I wanted to build out a pipeline so I could start sort of making this into a real project. So that's what I did. And here I'm using DVC exactly for that. So basically, this is my DVC pipeline. So it's defined like this very simple YAML that has different stages with their dependencies and outputs. And what DAGsHub does is it parses this information and it turns it into this beautiful data, like interactive data pipeline. So let me just open this on the full screen. So even if you have non-technical team members, you can actually guide them through what's going on in your project in a way that makes sense by showing them this pipeline. So I can tell you very simply that what I'm doing here is I'm taking data from the internet. This is a standard data set. I'm starting to track it with DVC. That's the dark blue node. I'm processing it so it's ready for training, splitting it into train and test set. Then I'm training a model on it and evaluating that model, getting some prediction examples and test metrics. And this is completely interactive. What I mean by this is if you want more information, you can just open one of these nodes to see more information about the data. I can open one of the stage nodes to see what commands I'm using to process the data. I can even see my metrics. So let's say I want to see my test metrics. I can open this node and I can actually see how my model is performing straight within this pipeline, which is pretty cool. The last thing I could do here is, let's say I want to see my prediction examples because that's the way to qualitatively assess how the model is doing. So I can open this node, click this link, and it's going to take me directly into that folder so that I can now sort of open this data. I can move around in my example folder very intuitively with the keyboard and just check out what's going on. So cool, I have this pipeline. My sanity check has been successful. The next step, which I actually did in parallel, was, okay, it's time to make this a bit more reproducible, right? So I wanted to work with some team members, and I wanted it to be easy for them to pull the data and the code and everything and just start working on it. So after building this pipeline, or in parallel to building this pipeline, I started versioning my data. So you can see this, all the blue nodes are versioned. My models, of course, and my examples. And what that means, or what DAGsHub provides on top of that, is the ability to actually browse this within the UI. So I can go to my data tab. I can click source data process. Let's say I want to see my test data. Let's go to the computer lab, and I want to see the images for the computer lab. I can click them. They open. You can see that it's indeed a computer lab. And I can see the depth map for that image as well, which is great. I can share this again with team members so that they can see what I'm working on. And for example, if they just want to download the model to try it out, they can go, again, if I go back to my source, I want to take the model, I can click this, and I can actually download the model directly from the UI and just use it without typing a line of code, which is pretty cool. Okay, so step 3 is done. Everything is versioned using DVC. And now I want to start experimenting, right? So the first experiment I decided to run was let's train the model for longer. Like the first model, I wanted to train as quickly as possible. So I created this branch called epoch testing. And you can see, by the way, I'm switching to a different branch. Now I'm going to the model of that branch. So that's also pretty intuitive if you want to look at move between the different experiments that you're doing. So again, I'm now in epoch testing, okay? And I started experimenting. And what happened is, I'll go to the experiments. So what happened is I got these 3 experiments. You can see that each one is trained for a different amount of epochs. I guess this one is more intuitive. So it's trained for a different amount of epochs. And I can actually click, choose multiple experiments, click compare, and then go and compare them. And so within this comparison, I'm seeing these different experiments, and I see a tabular comparison. So I can see all the parameters and then the metrics side by side, making sense of them. But I also have this parallel coordinate plot where I can see the effect of the different parameters on the different metrics that I'm using. But something here was kind of fishy. And then I went down to the side-by-side comparison. So the gray experiment is the experiment with 50, the longest run experiment. I suddenly noticed that this doesn't make sense. There's no clearly better experiment here. And I didn't understand what's going on. So as usual, I went back to the data, because that's most of the times where the problem comes from. And I checked my process data, and I couldn't find any issues. It makes sense. But then I went to my example folder. Let's go to the epoch testing. That's the correct version. So I went to my example folder, which is here. And one thing that popped to that sort of I saw immediately was the colors didn't really make sense. Like in my training data, it seemed like what's black is closer to the screen, but here everything that was closer to the screen was actually brighter. So it didn't really, I didn't understand what's going on. And so at some point it hit me, and I realized that I was flipping the colors of my predictions. That's why all of the metrics were funky. So I immediately fixed that, and I pushed in a new branch called epoch testing fixed. And you can actually open them on DAGsHub and again, compare them intuitively. And you can see that the image now makes more sense with respect to what you'd expect with a depth estimation. Again, darker is closer. And in fact, when I went to my experiments and I created these new experiments again, these were the final experiments that actually worked. I could compare them, and then it made much more sense. So again, I can see my tabular side-by-side comparison. I can see my metric side-by-side, but also this. And now when I go to my side-by-side charts, everything makes more sense. So these 3 are the higher the better, and these 3 are the lower the better. So you can see that the right experiment, which is 50 epochs, is best on all fronts, which is exactly what you'd expect. So I was happy. 2 things. One thing I forgot to say is how did I create these experiments? So with DAGsHub, you can create experiments with an MLflow, with MLflow tracking. So I did not do this for this project. But if you would want to, you don't need to change anything about your MLflow code. You just add DAGsHub as a remote URL. So you have your MLflow tracking server here. You can add this to your MLflow as the MLflow tracking URL, and then it just works. But here what I did is I used Git experiments. What that means is for every experiment that I ran, I saved my parameters as a params.yaml file and my metrics as a metrics.csv. So if I open this, you can see that my experiment parameters it's like human readable. You have the parameter name and the value. And then the metrics are a CSV. So DAGsHub has this interactive CSV viewing capability, but it's very simple. So 1 column name, value, timestamp, and step. And let's say you want to just look at the raw loss, and you could filter it as well and only see the raw loss if that's your cup of tea. But obviously, you can see it in the Experiments tab in a more convenient way. So that's how this experiment was created. Every time you save this and you push this to DAGsHub, DAGsHub parses that information and turns this into the nice UI that you just saw a moment ago. So that was one thing that I overlooked. I see that I got a star since I started this presentation, so someone has really liked this project. So that's one thing. The last thing I'll say, and I'll remind you, if you have any questions, please feel free to ask them in the chat. The last thing I'll say is this project is open source. So everything that I just showed you, you can use, you can download it if you're working on depth estimation. It would be a pleasure to see you use stuff to depth, but we're also looking for contributions. So I created a few issues here. I think this is fun, like I'm working on this project in my spare time. If you want to work on this as well, then we invite you. And in general, I'll say DAGsHub is completely free, definitely for open source, but also for private projects. You can sign up and start using it. Like there are limitations on private projects, but basically you can see all of the features exist for private projects. You can start using it, enjoy all of the benefits. And I think that's it. I'll end here and let you ask questions. If you're working on open source data science projects, please join DAGsHub, join our Discord server. You can see the link in the chat. And please ask questions if you have any. I'd be happy to answer. If you want, you can join the video or you can ask in chat. Don't be shy. Questions, anyone? Anything that wasn't clear that you'd like to know? Okay, so I'll just answer the last question. I mean, if you have more questions, then feel free to ask them in our Discord. We'll be there to answer any questions. But with regarding Micah, your question about supporting closed projects. So if you join DAGsHub, you have unlimited open source projects, unlimited private projects. The limitation is up to 3 collaborators. If you want more than that, then it's part of the paid tier. But the idea is you can get started with DAGsHub without worrying and get all of the features. Like there's no feature limitations. It's just a limitation on the amount of collaborators. But basically that's it. Everything is supported. And you can even connect external things. So this was a question that came up in the first round of this talk. Basically, if you want to work with, so like I said, every DAGsHub projects come with integrated DVC storage. But let's say you already have your cloud set up and you want to use S3 or Google Cloud Storage. You can connect your Google Cloud Storage bucket to DAGsHub and give us access, and we'll give you all the features. Or you can even just connect it without giving us access, and we'll show you the structure and all of the files and give you a link to the file that you're looking for. So another question, DVC support, it seems like it's interlinked to DAGsHub. Will we be able to have a separate DVC that we're hosting? Exactly. Yeah, exactly. So I read your mind. This is also one of the superpowers that you get with DAGsHub. You join and then you can read other people's minds. But yeah, awesome. So thank you everyone for joining. Again, please feel free to join our Discord. We're active, we're responsive. We'd love to hear your questions. If you have suggestions, some way that we can make DAGsHub even better for you, your use case, your team, then we'd love to hear it. We're always on the lookout for interesting projects. So if you are working on, we'd love to feature you. And thanks again for joining. Bye, everyone.